Hello, everyone. This is Juanle from Institute of Geographic Sciences and Natural Resource Research in Chinese Academy of Sciences. Now I have a talk about big estate management development and its application for Sustainable Goal 15. As we know, on September 25th, 2015, the United Nations Summit on Sustainable Development was held. At this conference, the 193 member states of the United Nations formally adopted the Sustainable Goals, including 17 concrete goals. This goal is aiming to fully address the social, economic, and environmental dimensions of development between 2015 to 2030. Here is the umbrella of this SDGs. It has three levels, including the economic level indicators, the society indicators, and the environmental and the biosphere indicators. So sustainable goal number 15 is located in the bottom level. It's very basic level for life on land. Here you can see. But how is the process of the Global Sustainable Development Goals? That is a big challenge for data available. This slide, we can see there are more than 50% of the indicators without data support. We can see 16% no method, no data support. 39% only method and no data. So this is the big challenge. But the biggest data can make this possible to use the big data technology to support the Sustainable Development Goals. The most urgent task of technical facilitator mechanism is to achieve a breakthrough in the data and matrix methods of Tier 2 and Tier 3, as I showed in the last slide. So this is an opportunity. But how to do it? We need more big estate technology. The macro, dynamic, and objective monitoring capacity of the big estate can provide SDGs with rich information of large scale and periodic changes for decision support. Here is some example from big data at social media, at statistic data, at remote sensing data, and even the insight, the observation data. What's the number 15 goal? It's aiming to protect, restore, and promote sustainable use of terrestrial ecosystems, sustainably manage forest, combat desertification, and halt and reserve land degradation and halt biodiversity loss. So it focuses on the forests, the desertification, the biodiversity loss, and even the whole land ecosystem. There are 7 targets and this goal. Today, my talk will focus on the number 15.1.1 forest area as a proportion of total land area, and number 15.3.1 proportion of land that is degraded over total land area. These 2 concrete targets. So let us see the first the forest type distribution along Yangtze River Basin in China. This is a case sharing. For Sustainable Goal 15.1, by 2020, ensure the conservation, restoration, and sustainable use of terrestrial and inland freshwater ecosystems and their services, in particular forests, wetlands, mountains, and drylands, in line with obligations and international agreements. So for these indicators, the forest area is a key number. How to get this and make it sustainable in the next 50 years. Currently, we can see the FAO released the report. It was said the world's forests are still declining. It's decreased the number. But that's still a problem for forest monitoring. For example, we haven't good data with high spatial and temporal resolution. The current data usually is used in large macro scale, but it's difficult and it's not easily used in regional scale. It's not so accurate. For example, in global forest cover map in right side of this slide, we can see there are 4 classifications in local scale, and the spatial resolution is not so high. Also, in the regional or country level, for example, for China forest cover map, we can see there's still without a detailed forest type information. Here is the forest cover change product in the world. We can see there are some. It's good for global study, but in China we can see in southern region some water, some rivers are also misclassified as forest. And also here is the forest and the non-forest product, but it's just two class here. We cannot see the detail of the forest type. The Yangtze River Basin spans 3 major economic zones in eastern, central, and western China, and it's a very large basin in the world. It has formed rich forest resources, but it still have this challenge and threatened by the social and economic development in this region. So focus on these SDG indicators, we try to mapping this forest map in this region. Here is our forest classification system. We divided the forest into evergreen, needle-leaved forest, evergreen, broad-leaved forest, that's deciduous, needle-leaved forest, deciduous, broad-leaved forest, and mixed forest. And then we collected images, more than 5,000 scenes images from Sentinel-2 and Landsat satellite was collected in the years between 2015 to 2019. And here is the method we used for classification. 3 steps here. Firstly, image composition based on novelty rule. We found at least 4 rules to merge to composite these images, because in this region it's not easy to find a clear image without cloud, without raining. So we need to composite more images to get the good quality images for analysis. The second is SST features and their importance analysis for forest type classification. What's SST features? It's mean spatial, spectral, and temporal features. It's important for image classification in this study. And then the third one is forest type classification. We use the machine learning method in Google Earth Engine platform. This is some field sample data collection in this study. More than 5,000 field data was collected in past years. And also we use the global cover validation data in the website. Here is the process of image composition. We can see we can use the rules like composition years, composition period, and distance to cloud, and reflectance assessment. Then we find good quality images to use in this study. Here is some evaluation. Yeah, what's the quality of the images. Here is the spectral, spatial temporal feature for forest classification. Combined with the Sentinel-2 and the long-time series Landsat images, the SST feature set, including 16 features of forest classification, was established by using gray co-occurrence matrix, time series harmonic analysis, and random forest RFE algorithm. So that is the assessment of the importance of SST features for forest type classification. We can see spectral features were more important in classifications involving complex compositions. Temporal features could be very important in identifying forest types with distinct evergreen and deciduous growth patterns. And the spatial feature produce better classification results for forest types with different spatial structures. And also the DM factors are used to support the classification. Here is the result of this classification method. We can see the forest coverage rate of the Yangtze River Basin is about more than 40%, and the classification accuracy is even high. And we also can get the location and their distribution characters of evergreen broadleaf forest, of deciduous broadleaf forest, and mixed forest, like this. Okay, this is one example. The second one is about land degradation risk identification based on remote sensing along the China-Mongolia Railway in Mongolia. So land degradation is an important ecological and environmental problem facing the whole world. The SDGs number 15.3 aims to combat desertification, restore degraded land and soil, including land affected by desertification, drought, and floods, and strive to achieve a land degradation neutral world by 2030. Mongolia is currently experiencing severe land degradation challenges, and here is the number from the Ministry of Nature, Environment and Tourism of Mongolia. 76.8% land in the country has been desertified. Yeah, this is the current situation. And in this case, our study region is along the China-Mongolia and Russia Railway. It's in Mongolia section. Yeah, it's from south to north. There are different stations here. Yeah, this is the general map. We can see some rail station and even the main city along this route. We use UAV for this study. Here we can see in north side, in the transboundary area of Mongolia and Russia, it's here have more mountain and forest, and even the transboundary river, Selengo River here. And then when we move to south, we can see in the Dahan region, they have farmland and with good water resources here. The enemy has boundary, and even the agriculture here is very developed. Okay, here is even to south we can see the farmland here, and also with mountains and has boundary, and then we can see the grassland in the middle region of Mongolia, and in the railway road we can see the real steppe, the mountain steppe, and even the desert steppe here. Yeah, this is the south region, more desert steppe here. Okay. Here is we can see the black color in this image is road. Yeah, there is highway, and along the highway we can see some desert region and even the grassland here. And here is the south part of Mongolia. We can see they also have some desert steppe and even the wind electronic facilities here. This is south region. Okay, so this is the general situation. So we also collect the remote sensing images to cover the whole Mongolia and even this road to find how to get the land degradation information here. This is a land cover mapping technology route. We can see we firstly use some indicators of, for example, the water indicator to find where is the water region, where is the land region. Then we divide vegetation and the others, and the vegetations are divided by forest, by meadow steppe, and even the real steppe, desert steppe. Yeah, totally we can see the forest, steppe, cropland, water, built areas, barren land, and ice are classified in this method. And here is the thresholds we selected in general in this region. And also we need some field trip to make ground truths, to validate the result, and we do this work with the Mongolia people together. Here is the result. We can see the land cover mapping along the railway. There is a buffer region along the railway. We can see according to the spectral distribution pattern of different land types in regions along the railway. In 1990, 2010, and 2015, sand and desert are constitutively distributed in the middle part region. The barren land is constitutively distributed in southern regions, and desert steppe is constitutively distributed in central and southeastern regions. This reflects the obviously transitional characters along the railway. Here is some land degradation information we captured from the land cover maps. This is 1990 to 2010, the land degradation region. The red color means the degradation. Here is the same period, the land restoration map. So land degradation and land restoration is a two different direction change of land, but they happen in the same time, but not in the same location. So this map shows why they have the good restoration region in this study area. We can see the east part, there is a green color, the deep green color. This means they have a good recover of the land degraded situation. This is 2010 to 2015, the land degradation trends along the road, along the railway. This is the land restoration in the same period. We can see in the middle and also in the middle and the east region, they have good land recover. Okay, the overall distribution of newly increased degraded land demonstrate an obviously zonality feature and are mainly distributed in the middle region along the railway. The land degradation degree gradually increase from north to south. The land degradation from non-degraded land to desert steppe is most dominant type observed. There had been an increase in the amount of land being restored, and the ability to restore land has been improved, especially in the last 5 years. But land restoration lags behind the land degradation process. So the general situation of this region is land degraded. So this is still a sustainable challenge, sustainable development challenge here. And also we try to find what's the reason to cause this land degradation or even the land restoration. The nature factors, we can find the temperature, the precipitation change in this region. We can see the temperature is increasing in the past 50 years, and the precipitation is a little bit decrease in the same period. This is one reason from the nature. And also we can see the social economic factors. The number of animal, for example, the goat, is increased continually. So overgrazing is maybe one of the reasons in this land degradation region. And also excessive mining activity enhanced by mining enterprises along also could accelerate this trend. And rapid urbanization is also a factor. Here we can see the population increased totally in Mongolia, and also in the city region. And also increasing infrastructure development is maybe also the factors influence the land degradation in this study region. And we try to put this study result to the website to let more colleges, more people can visit this collaborative and innovation platform to see more land degradation, monitoring study, and other related study in the transboundary region along the China, Mongolia, and Russia. Okay, this is my presentation about these two stories to support the SDG using the big Earth data technology. Here is some reference. Maybe you are interested. Okay, this is my presentation. If you have any questions or comments, welcome you connect with me. Thank you.